prepare the standard solutions in the titration between sodium thiazocarbonate for the decahydrates and hydrochloric acid. The challenges that follows this titration, then the likely questions, their answers, then maybe probably the correct endpoint. So first of all, you might be finding the endpoint challenging, maybe because you did not get the right product or you did not prepare the standard solutions very well. If you listen to me very well, you will know the best thing to do. The first challenge one have to face is that this particular salt, that's the sodium carbonate decahydrate, is not stable. It's an efflorescent. It loses some of its water of crystallization when exposed or when not protected well, and that will affect the mass you are measuring. So it is expected that you make sure that your own is still the decahydrate, what the label it is. First, you can use heating to analyze that one, of which I will not be showing in this video. Or you can produce your own decahydrate by dissolving in water, making sure it's saturated, then recrystallizing it at a certain range of temperature, at least from 32 degrees or 25 degrees downwards, down to minus. You just crystallize it. The crystal form of it is shiny. It's not dull. Anytime, if you buy the dull one that is just having solids with dull appearance, it is not the decahydrate. The decahydrate has this shiny, glassy appearance. You see something like glittery, that's when you know you have the real washing soda. So I've settled that one. So the first error comes from you getting the wrong decahydrate, and I've told you what to do for you to get it by yourself. I've finished preparing that of the decahydrate. You are required to measure 5 grams and dissolve in 5 grams of the sodium thiazocarbonate for decahydrate is expected to be contained in 1 dm cube of the solution. So what you need to do is just you use your weighing balance, measure 5 grams as was instructed of this, then dissolve in this so volume. This here is 1000 ml. This is 1000 ml, of course. Then this ring is the 1000. So you know I did not fill this. So if you measure, this is the digital balance. If you just press here, see it's already that started, and now everything you place here will be measured well. You place your filter paper and add until you get the mass of the filter paper, add to the mass of the salt. When you get the mass, you dissolve here and shake well. I finished preparing my B. This is 3 liters of B. This is it, which means I'm actually ready for my students, even though they don't know, which is the rule. You might not reveal this to your student, but if you didn't train them well, you can, because they might go there and mess up. Okay, so if you measure that 5 grams, you dissolve it in so volume of water like this and shake. After dissolving, you use another water and add it up to this level. So if you want to make 3 liters, this is just 1000 sec, which is 1 liter. If you want to make 3 liters, you just say 5 times 3, which is 15 grams. So you measure 3 liters of water, then measure 15 grams and dissolve, depending on the number of students you have. You are required to keep 150 cm cube of both solution A and B for each student. So you can multiply 150 ml by the number of students you have, and now know the number of liters you require to prepare. So that's it for solution B. Then for solution A, the instruction here is to measure 8.5 cm cube of HCl and then dissolve it in a given volume of water, then add up to 1000. The problem here is that the HCl is also it has challenges. The challenge, this stock solution here you are seeing is the stock solution of HCl. You know the concentration of hydrochloric acid, this stock solution, by assessing the SG. When you get the SG, that's the specific gravity, you can now tell the percentage concentration. So if you can predict the percentage concentration, you can now talk about the molarity of it. The challenge here is that they just wrote 8.5 cm of HCl. They did not specify the percentage. And this gives chance for maybe a kind of a larger range where the endpoints may be accepted, because this is not specified. Sometimes you might buy the one that have been diluted. Sometimes, being a volatile acid, if you open it, you see fumes going out, and as the fume is going out, the tendency that the concentration is decreasing is there. So what must you do here first? I want to teach you how to know the specific gravity of the HCl you are using first. What you need to do is forget what they labeled there, check if it is still what it is. To know the specific gravity of this my HCl, I need this measuring cylinder. This is actually, this is 10 mil measuring cylinder. Then I need the weighing balance, which is here. Then the acid itself. Remember that density is actually mass over volume. So you see that, yes, of course, I think density is actually mass over volume, yes. So you have to put a known volume of this and measure, that's know the mass of this particular cylinder first, which is what I'll do now. So let me know the mass. I guess it reaches 0, then let me know the mass of this cylinder alone. So let me try to dry it very well, I'm supposed to, but the water there is insignificant. Okay. From here it reads 16.73. 16.73. 16.73. That's the mass of the cylinder alone. I've taken record of it. Remember, it's in gram. So what I will do next is to add a known volume of the acid, of the raw acid undiluted. This is the stock acid. It's the concentrate. I want to know the SG, which can now see is a fuming acid. Hope the camera can get that fumes, and that makes it very sensitive to the environment. So with this, let's have to, okay. There are air bubbles. I'll avoid that. Okay, right now, this is 10 mil. I want to add 5 mil to it. So I do it in 2 ways. Let me wind down to 5. I think the reading is clear in the camera. Okay, that's 5 mil. I'll transfer the 5 mil into this cylinder and know the new mass. Okay. Safely. Make sure no drop for accuracy. Okay, now it's obvious the digital balance is off. What we will do is lift this before you on it, because if you stay on it, although you can on it, lifts 0. When you lift it, it will still give you, that's reverse way, but let me take the other way. Okay, I think it's showing 0 there. We already know the mass of this alone, so let us know the mass with 5 mil. Okay, there is a little discrepancy. Okay, no discrepancy, still 5 there. So what's the reading there? This is 22.56. I hope that's what it is, 22.56. So, but we now have plus 5 cm3, we have 22.56. So remember that density is equal to mass over volume. What I will do next is do my calculation now. I have to know the weight of 5 mil by removing the weight of the cylinder itself, which is 16.73. So what we have here is 16. We have 0.56 minus 16.73. 16.73. Okay, so we have 5.83. So 5.83 is the mass of 5 mil of this acid. So since density is equal to mass over volume, what will I do now? I'll just say 5.83 divided by 5 mil, because the volume of this is 5 and this is the mass of the acid. So the density will now be 5, don't worry, 5 divided by 5.83 divided by 5 is 1.16. So 1.16. The density of this acid is 1.16. So the 36 or 37% concentration of this, oh, I forgot to close this. The 36 or the 37% concentration of this is supposed to be 1.18. See, we are 0.02 less. That means this is still a bit close to give what we expect. So the highest percentage for the concentration is to give you 1.18 as the specific gravity, but the real specific gravity of this acid here is 1.16. Since I've known the SG, you can equally maybe browse to find out HCl with 1.16 specific gravity. They will tell you the equivalent molarity. Remember, the molarity is the concentration in mole per dm cube, which is what will now determine what is present there. Or if you need further guidance, there is a formula and other mechanism you can use to, or rather use titration to know the actual molarity, but it's already established. But the molarity is from 10 mole to 10 to 12 mole per dm cube as it is now. That is the molarity for this concentration. So at least we have learned how to do, how to calculate the specific gravity or determine the specific gravity of acids. This is also applicable to other acids apart from HCl. Now, the next thing is we go back to the instruction. The instruction says measure 8.5 and then dissolve in 1000, meaning solution A will contain 8.5 cm3 of concentrated HCl per 1 dm cube of solution. See what you will not do. To fill this till the rim, that's fill it with water, then go and measure 8 and dissolve. That's not the rule. What you need to do is fill to any level like now, then measure that 8.5 and add in, shake well, then use water and add up to this mark, because the question says, the instruction says 8.5 cm3 per dm cube of solution. So that means both the solvent and the solute will sum up to 1000 cm3. Not that you should use the solvent to make up 1000 before adding the solute. No. The HCl here is serving as the solute. So both the volume of the solute and volume of the solvent should sum up to 1000. That's why you should not fill to this. Just fill to any certain volume and add that 8.5, then add up with water till that mark. What I'm saying is that I don't need to, this is distilled water, this is distilled water. I should not fill all till this ring. No. I might fill it here, then measure my 8 and add, shake well, then use water and top to that mark. That is what you should exactly do. So let me do it for you to see. Remember, all these sophisticated apparatus you are seeing I'm using are available for sale. You place order. If you need the pipette pump, you need the bulb, the burette, the tap. These reagents, to get accurate results, you can also buy from Her Majesty Easy World. So I'm shifting this for us to prepare that. Now, this is the raw acid. Simple. I don't even need to bring out small. Like normal, if I don't have all this, I will pour some, then use this one and measure, which is more tedious. But hence I have this. This is a 10 ml graduated pipette. It's 10 ml. So the maximum you can measure is 10 ml. The advantage of using this type as a teacher, as a chemistry teacher, is that you see the marks are simple. You can get 0.5 easily. You see, this is 8, and 8.5 is very clear. Unlike here, that is, the marks are congested. They are very much close. So to get the 8.5 will be more difficult here. But using this type, it's very, very easy. So place order and you get all these things and other laboratory apparatus. So here we go. The camera is getting it well. So what I'll just do is pipette this and then reduce to 8.5 to keeping this open. Okay. Okay, that's my 8.5. So what I need to do is wind down. I think the camera is getting it. That's 8.5. Then I'll bring you here. See? And now dispense, spell it. Okay. And close this as fast as possible. Keep it away. So shake well. Okay, then I have to now add up to the mark with distilled water. So just pour until it comes to that mark. You have to be very careful here. If pouring alone cannot do it well for you, so you just still use this. It's even better to collect the remaining acid. You pipette this. I use this and try filling it. Keep your eye not to see double line. Yeah, that's on the line. Yes, you got it on that ring. Exactly, no mistakes. So you have actually prepared solution A. So you are advised to allow for acid is easier, you can easily mix well. Yeah, but for this I prepared it a day. So you can prepare this at least a day or 2 days before the exam. Preparing it in the morning will give error because of the fact that not the whole carbonates have dissolved. So you are advised to prepare this a day or 2 before the exam. Because that morning, not the whole, you get an endpoint which is less than normal because not the whole carbonate have actually dissolved. So, but I will run the titration right now. So let me now bring out the one I will use. I think this is up to 15 ml. Here is the setup. I need the funnel to fill this. The digital weighing balance, everything you see here are available for sale. They are very much affordable and reliable if you buy from the Easy World. And I will help you. I will teach you how to use anything you buy from me because you are buying from the experienced person. Of course, that's the advantage. So I will fill in the acid into the burette. So I will make sure the base, I have not even washed it out, so it's good. Make sure the tap is closed. Yeah. So my initial now is 0.00.
Let's take a break and see this majestic periodic table. Then the clear answer to this analysis will follow immediately. The electronic configuration itself is all written starting from hydrogen down to the organesium, that one bearing atomic number of 118, that's up to 118. Then coming to the classification of the elements, this is just purely majestic. It indicated many groups and classes of elements that you never know they exist and explained most trends. So it is purely a summarized chemistry textbook in form of a table. You see that classification you see there, you see the alkali earth metal, the alkali metals, the halogens, the chalcogens, indicating the common names of each group. Apart from the one that is commonly known like the halogens, you have the all-formers, the chalcogens, the nitrogen family. This table has come to answer your questions as a chemistry teacher, especially if you are in the class teaching. Your job is just to point at that table and the information you want will be there for you. Then this table do not only just contain the configuration, it shows the order, the half-bar order, how the electrons fill the orbitals. Why do we write 1s first? Then after 1s, we go to 2s, 2p. You see the arrow down indicating. And then it shows the number of shells present and the maximum electron each electron shell can hold. They are common named the K shell, the L, M, N, and also show the formula for the maximum electron each shell can hold. So I cannot mention them all. Place order for your own copy of this majestic periodic table. You will not regret it. I've come to help you learn chemistry. I've come to help you teach your students very well. Present this. Can hang it everywhere. Remember, the periodic table, the Mendeleev table, is one of the most popular tables, and that's the table that represents science, even though it's chemistry. But anywhere you see that table hanging, automatically you know that this particular institution or this organization is scientific. Much love from me to you. Remain majestic.
Hi, I wanted to tell you that you can contact Her Majesty World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Her Majesty's World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
The most advisable time to take your initial, let me turn this around so that camera can read it. Okay. Captured. So the most appropriate time for you to take your initial burette reading is just before you start titrating. So here is the 25 ml. Here is 25 ml volumetric pipette. But this one I used is graduated pipette. Okay, then this is the conical flask. You rinse properly. Okay, it's time now to get our base. I don't want to pour out because I have this to pipette it exactly. Fix this. Okay, that's it on the mark. So the dispense. So this will siphon the liquid and also empty the pipette. A very simple and easy way. Okay. So what next? Keep this aside. My indicator before titration. Okay. That's it. There we go. Because this is the first titration, keep it that way. Shake. Shake. Okay. Yes, we are cutting the orange. So that is, by the way, thanks for watching. You have to chat me with the number you see there on the screen, the likely questions, the answers, and other further guides that you need, how to maybe guide your students, do it well. Remember, this video is exclusively for teachers actually, so you chat me up with the number you see on the screen to see the correct endpoint. Then what must you do? How to even use the sodium carbonate within your reach, assuming you cannot see the decahydrate. What must you do to get the required thing to avoid failing your students? So see you as you chat. Thank you for watching. Bye for now.